We will start our problem with a square. Then, from the top left corner of the square, we will pull a line to the bottom side of the square. And from this intersection point, we will pull another line to the top right corner of the square. Finally, we're going to pull a line from the top left corner once again, but this time to the right side of the square, so that its intersection point with the right side of the square has the vertical distance of 4 from the bottom side of the square, as you can see on the sketch. Now, you can see that those two lines have formed two inner triangles, and if the right triangle has the area of 10 and the left triangle has the area of 30, the question is, can we somehow calculate the area of the whole square? This problem was sent to me by one of my subscribers, Jan, from Czech Republic, and he stated that this problem was given to him in his high school math competition. And if you guys want to try it out for yourself, you can pause the video right now and then come back and check the solution. Alright, so let's solve this one. So first, let's label all the vertices of our square as A, B, C, and D, and let's label the remaining vertices and intersection points as E, F, and G. Now, for the sake of easier calculation, let's label the side of the square as S. So, let's first remind ourselves about the triangle, specifically about the area of any triangle. So the area of any triangle will be equal to the product of its base and the height divided with 2, and this is exactly what we're going to use in our case. So first, let's have a look at the triangle DEC. This triangle has the base of DC, which is equal to the side of the square S. And if you take a look at the vertical side of the square, we can slide it to the right to the point E. This means that this triangle has the height of S as well. So we can write its area as S times S over 2, which equals to S squared over 2. So now let's take a look at another triangle, at the triangle FCD this time. You can see that the base of this right-angled triangle is equal to S, and you can see that it has the height of FC. But if you take a look at the vertical side of the square once again and slide it to the right, you can see that this vertical side consists out of two segments, the segment BF with the length of 4 and the segment FC. So this means that the segment FC must be equal to the difference between the side of the square and the segment BF with the length of 4. So let's write down the area of this triangle as well as S times the quantity of S minus 4 over 2. Alright, so now let's take a look at those two triangles once again, but this time we're going to use the triangle which is common for both of the areas of those two triangles. And that triangle is this blue special triangle DCG. Let me show you. Let's first take a look at the triangle DCE. We can write its area as the sum of the areas of the blue triangle DCG and the triangle DGE with the area of 30. Now, since both areas are equal to the triangle DCE, we can say that those two values are equal to each other. And from this, we can conclude that the area of the blue triangle is equal to S squared over 2 minus 30. Alright, but now what about the triangle FCD? Well, if you take a look at this triangle, you can see that its area also consists out of areas of the blue triangle DCG and the triangle GFC with the area of 10. So again we will combine those two equations, since both of them are equal to the area of the triangle FCD, and we will get the following. From this we can conclude that the area of the blue triangle is equal to the S times the quantity of S minus 4 over 2 minus 10. Alright, so now let's grab those two equations. And you can see that both of them represent the area of the same triangle, DCG. So we can say that they are equal to each other. Now, let's expand everything by 2 to get rid of the fractions, and then let's use the expansion distribution on the right side, and we will get the following. Now we can cancel s squared on both sides, and if we rearrange our terms, we will get the following. From here, 4s will be equal to 40, which means that s must be equal to 10. Alright, so now remember we are looking for the area of the red square, and the area is simply side squared. So we're just going to substitute the value of our side, and we will get that the area of the whole square is equal to 100 squared units, and this is our solution. From here, guys, you can also find the areas of the individual triangles for the example triangle DCG if you want to, but I will leave that to you. So I hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. Of course, if you found another way to solve this interesting problem, please write it down in the comment section below, as you always do. And until next time, see you guys and take care.